Good morning, everyone. Okay, so far we were discussing about analysis of AC circuit. Okay, let me conclude that one. We have one more to learn, that is RLC. Before that, we will just revise what we have discussed. Okay, first about resistor, that is analysis of AC through a pure resistor circuit. What was our finding? Our finding was, okay, first, when you are answering, first you have to draw the circuit diagram by keeping a resistor parallel to a sub AC source. Then here you have to write V is equal to Vm sin omega t. Here you have to write R. And we have found that the applied voltage V is equal to Vm sin omega t and current is I is equal to Im sin omega t. And we found that the waveform of voltage and current are in same phase and that was the reason, because there is no phase difference between current and voltage. Also, we have found that sorry. Uh, we have also drawn the phasor diagram, and there also there is no phase difference. This is how we have learned resistor AC analysis of AC to a resistor. So first, whenever if someone asks for some derivation, some question, if it is asked in the question paper, what you do is you write the heading analysis of AC through a pure resistor circuit. Then you draw the circuit diagram, write the expression V is equal to Vm sin omega t, I is equal to Im sin omega t, and then you, based on that I and V, you draw the waveform and also you draw the phasor diagram. So here everything should be clear. Okay, this is of voltage, this is of current, and here also this phasor is of voltage, this is of current. And after that we have learned inductor. So what was the difference? So instead of resistor, I have drawn inductor. There is no difference in voltage because it is applied voltage. So there is no difference in voltage formula. But if you derive current formula based on the equation V is equal to L di by dt, this how you should learn means you have to learn this formula by heart, L di by dt. From this you have to integrate and find out what is the expression for current. Integrate the below equation and find out what is the expression for current. So it will be given I is equal to Im sin omega t minus 90. That means there is a phase difference between voltage and current. Okay. So suppose this is current. I can draw like this. So there is a phase difference between voltage and current. Then if I go for a phasor diagram, you can also say that phasor diagram is drawn like this. Voltage is leading. So what I can do, I can mark this as V, this as, sorry, voltage is leading actually. So this is V and this is I. Okay. After that, we have learned about capacitor. So if someone asks, write down necessary equation and waveform for analysis of AC through capacitor, then you draw the circuit diagram. There is a capacitor, there is pure capacitor is connected parallel to AC source. There is no change in voltage equation because voltage Vm sin omega t, that is actually the applied voltage. And if you derive using I is equal to C dV by dt, there you have to use this formula. I is equal to C dV by dt. Okay, so you will be getting current equation like this: Im sin omega t plus 90. Okay, there you can draw the same waveform. Okay, I'm drawing the same waveform first. And which one is leading? Current is leading. Current is leading actually. So as per this waveform, this is current. The color brown in color is current. The blue is voltage. So current is leading. Again, same phasor diagram I can draw, but mark this as voltage and this as current. Okay. Afterwards, what we have learned? We have learned RL circuit. So what was RL circuit? RL was combination of resistor and inductor. So you should draw something like this circuit diagram. You should have series RL circuit. So see, both resistor and inductor should be connected in the series manner. So it will be connected like this. Voltage is same. Voltage equation is Vm sin omega t, and we are not. We can, of course, we can derive current, equation of current, but we are not doing in that manner. What we are doing is from this explanation we know voltage and or from this phasor diagram we know that voltage and current are in phase with each other, and here also we have another phasor diagram of inductor where voltage is leading the current. So first you draw the current phasor, and on the current phasor what you do is you draw the voltage phasor also, because this represents the resistance. And here voltage is actually leading because inductor is there, so we can write VL here in voltage across inductor. And then you draw the hypotenuse, and then you take the phasor equation and solve it. That is how we have done yesterday. Again, in the case of resistor and capacitor, it's also same method we have to use. First, you can draw the phasor diagram. From the phasor diagram, you write the necessary equation and solve it. Okay, is it clear for you till now? Is it clear for you? One question will surely come, that preferably from resistor they won't ask because it is the most basic question. Inductor or capacitor or RL or RC. Either a derivation or a problem will come from this topic. Okay, is it clear for you? ഓക്കെ, ഞാൻ പുതുതായിട്ടൊന്നും എടുത്തിട്ടില്ല. ഇന്നലത്തെ ക്ലാസ്സിൽ പറഞ്ഞ കാര്യങ്ങൾ പറഞ്ഞതേ ഉള്ളൂ. റെസ്പോൺസ് ഒന്നും ഇല്ലല്ലോ. ആൾക്കാരെ എണ്ണം കുറയുന്നു, റെസ്പോൺസ് കുറയുന്നു. Okay, now let us discuss RLC circuit. That means all three are connected in series. Okay, all three are connected in series. I am repeatedly I want to tell you that if you learn RLC, that is analysis of AC through pure resistor, pure inductor, pure capacitor, you can do the or you can learn the topics, other topics, RL, RC, and also RLC, because almost same. Okay, now there is an AC source where resistor, inductor, and capacitors are connected in series. All three components are there. And then what I am writing is voltage V is equal to RMS value of applied voltage, I is equal to RMS value of current, Vc is equal to voltage drop across capacitor, and VL is equal to voltage drop across inductor, and VR is equal to voltage drop across resistor. Okay, so here all three components are there. So what I'm going to do is, I am okay. I will tell you another point. Okay, resistor is there. Okay, no need, no pro issue. Inductor and capacitor. As I said yesterday, both are of opposite nature. If there is an inductive reactance, you can cancel the same using capacitive reactance. If there is a capacitive reactance, you can cancel the same using inductive reactance. Both are opposite in nature. If you have inductor and capacitor, the effective in a circuit, the effect will be cancelled. The effect of reactance will be cancelled. മനസ്സിലായോ? അതായത് കപ്പാസിറ്ററിന് നേരെ ഓപ്പോസിറ്റ് ആണ് ഇൻഡക്ടർ വർക്ക് ചെയ്യുക, ഇൻഡക്ടറിന് നേരെ ഓപ്പോസിറ്റ് ആണ് കപ്പാസിറ്റർ വർക്ക് ചെയ്യുക. അപ്പോൾ ഒരു സർക്യൂട്ടിൽ രണ്ടും ഉണ്ടെങ്കിൽ അതിന് രണ്ടിന്റെ എഫക്റ്റ് ക്യാൻസൽ ആവും. അല്ലെങ്കിൽ ഇപ്പം ഇൻഡക്ടർ ആണ് കൂടുതൽ, ഇൻഡക്റ്റീവ് റിയാക്ടൻസ് ആണ് കൂടുതലായി ഉള്ളതെങ്കിൽ കപ്പാസിറ്റീവ് റിയാക്ടൻസ് അതിൻ്റെ ഒന്ന് മൈനസ് ആയി പോകും. ടോട്ടൽ റിയാക്ടൻസ് എന്ന് പറയുന്നത് ഇൻഡക്റ്റീവ് റിയാക്ടൻസ് മൈനസ് കപ്പാസിറ്റീവ് റിയാക്ടൻസ് ആയിരിക്കും. ഓർ ഇഫ് ദ കപ്പാസിറ്റർ റിയാക്ടൻസ് ഈസ് മോർ, the resultant reactance will be capacitive reactance minus inductive reactance. So based on that, we have three conditions. That is, first one is inductive reactance is greater than capacitive reactance. So based on the theory what I said, we have three conditions. First condition is, I'm marking here, inductive reactance is greater than capacitive reactance. So the total circuit behaves like an inductive circuit. Resistor is there, okay. We are not discussing about resistor. It will show resistive property, that is default. I'm keeping it aside. When inductive reactance or the value of inductance is greater than capacitance, what will happen is the circuit behaves like an inductive circuit. And I have a second case where capacitive reactance is greater than inductive reactance. I have a second case where capacitive reactance is greater than inductive reactance. So there the circuit behaves like a capacitive circuit. And finally, I have a case where capacitive reactance is equal to inductive reactance. That means the circuit doesn't have any reactance, because both the reactants are equal and both the reactants will cancel each other. So there won't be any reactance if XL equal to XC. Okay, did you understood all three conditions? ഈ മൂന്ന് കണ്ടീഷൻസ് മനസ്സിലായോ? Okay. Now, how to draw the phasor? Okay. So first, I am taking എല്ലാം ഒരേ സ്റ്റെപ്പ് കേട്ടോ, നമ്മൾ പഠിച്ചതെല്ലാം ഒരേ സ്റ്റെപ്പാണ്. ഫസ്റ്റ് സ്റ്റെപ്പ് എന്താ? I am taking current as a reference. So this is current. Now all three components are there, right? So what I am doing is I am drawing the voltage phasor here. So this phasor is for VR. So this is current, okay? And then I am drawing the another phasor. ഇത് ഏതിന്റെ phasor ആയിരിക്കും? കപ്പാസിറ്ററിന്റെ ആണോ ഇൻഡക്ടറിന്റെ ആണോ? So this is of inductor because based with respect to the current phasor in inductor the voltage is leading. So I am drawing VL here. What about capacitor voltage? Capacitor voltage is actually lagging behind the current. So I am drawing in this direction. Okay, now this is the resultant phasor. We have current, we have voltage phasor of resistor, voltage phasor of capacitor, voltage phasor of inductor. So as I said earlier, the inductive reactance and capacitive reactance will cancel each other. So this was our first condition. Once again, I will explain you that first condition was XL greater than XC. That is, the circuit is of inductive reactance. So I have drawn VL in such a way that the length of the phasor is greater than the length of VC. ഇൻഡക്ടറിന്റെ വാല്യൂ ആണ് കൂടുതൽ, ഇൻഡക്റ്റീവ് റിയാക്ടൻസ് ആണ് കൂടുതൽ. അതുകൊണ്ട് ഞാൻ എന്ത് ചെയ്തു, കപ്പാസിറ്റീവ് റിയാക്ടൻസിന്റെ വാല്യൂ ആ ഫേസറിന്റെ ലെങ്തിനേക്കാളും കൂടുതലാണ് എന്ത് വരച്ചിട്ടുള്ളത്, ഇൻഡക്റ്റീവ് വോൾട്ടേജിന്റെ ഫേസർ വരച്ചിട്ടുള്ളത് അല്ലെ. രണ്ടിലും നോക്കി നിങ്ങൾക്ക് ഡിഫറൻസ് മനസ്സിലാവും. VL is greater than VC. Now because it is opposite to each other, I can draw a new line where this line is actually VL minus VC. Because both are opposite, okay? This VL and VC are opposite to each other. So the resultant will be what? VL minus VC. So from this, what I am going to do is, like how I did in the last class, I am going to draw a resultant vector and marking this one. So this is nothing but VR plus VL minus VC. This is how you have to draw the phasor diagram. So if you look at this phasor diagram, you can see that it is almost same. Okay, VL minus VC. Here also it is VR. So total resultant vector. Okay, they haven't taken this minus sign. Okay, no issue, because we have taken this as VL minus VC. So it should come VR plus VL minus VC. Okay, now what we have to do is, we have to write the expression. We have the vector equation. So instead of VR, you write I into R. What is VL? JIXL, because current into inductive reactance and it is in the imaginary plane, minus J into IXC. And you can take I common. So from the above equation, that is this equation, I am taking I common, R plus J XL minus XC, where I can again write V is equal to I Z as we have done in the previous class. I can write V equal to I Z, but the equation of I Z is what? Equation of I Z is Z is equal to, sorry, equation of Z is Z is equal to R plus J of XL minus XC. And what is the magnitude? It is square root of R square plus XL minus XC square. Okay, same step ആണ് നമ്മൾ ഇന്നലെ കണ്ട ക്ലാസ്സിലെ. ഓക്കെ, ഇതേ സ്റ്റെപ്പ് തന്നെയാണ് അല്ലേ. നമുക്ക് ഇവിടെ വി ആർ പ്ലസ് വി എൽ ഉണ്ടായിരുന്നു. സോ ഹിയർ വി ഹാവ് മൈനസ് വി സി ഓൾസോ. ആൻഡ് then what we are doing, we are writing equation for VR and VL. Similarly here also we are writing equation of VR, VL, VC. Then we are simplifying. Okay, here said for an RL circuit the equation for Z was Z is equal to R plus J XL, but in this case equation was Z is equal to R plus J into XL minus XC. And what about the magnitude? Square root of R square plus XL minus XC square. Okay, is it clear? മനസ്സിലായോ? Okay. Similarly, next case. Okay, I will explain you how to draw the phasor. I am removing this. Okay, again, what is the second condition? Second condition, capacitive reactance is greater than inductive reactance. So what we do is we will draw the phasor. Okay, first we will draw the current phase. And there also we have three component RLC. So what I am going to do is I am going to draw the voltage phasor of resistance on the current phasor itself. So this is IR. Now what I am going to do is I am going to draw phasor of voltage across inductor, but the length is little bit less. What is the reason? Here the condition is XC greater than XL. So that is the condition. So I am drawing the length little bit less and I am marking this as VL. And again I am going to draw the third phasor of capacitor, where since XC is greater than XL, I have to increase the length of this vector. So this is VC. Okay. Now, again, the same point. VL and VC or XL and XC will cancel each other, but here the value of XC is greater than XL, so I should draw the phasor in negative direction, resultant phasor. And here I can write, VC minus VL. Okay, from this I have to take the resultant vector, From this again I have to take the resultant vector. Resultant vector should be drawn like this. And it is nothing but, what should be the formula? VR plus VC minus VL. Okay, so here you can see the formula. No need to derive and all, you can directly write. Now the formula of impedance, Z is equal to square root of R square plus XC minus XL square. And the last one, you look at the last one, XL minus XL equal to XC. So what is the advantage there? In that case, XL equal to XC, both inductive reactance and capacitive reactance are same. So at that time, the length of voltage vector of capacitor and inductor are also same. And it will cancel each other. So there won't be any voltage phasor for that. So when XL equal to XC, it will show no reactance, it will show only the resistance because reactance values are equal, so it will cancel each other. It will show only the resistive effect. So I can directly write V is equal to VR. So only this one is there, okay? Only this VR and IR is there. So I can say that there is no reactive effect, only resistive effect is there. So V equal to, I can directly write V, L and VC cancel each other. So V is equal to VR, Z is equal to R, resistance. So V is equal to IR, Z is equal to R, resistance. So this condition is called resonance. So at a particular frequency, when you are operating AC circuit, at a particular frequency, what will happen is the reactance of capacitor will be equal to reactance of inductor. So at that time, the circuit behaves like a pure resistive circuit. This condition is called resonance. Okay. So is that clear? Clear, Ayo? So for RLC circuit, there are three division. One is XL greater than XC. Second one is XC greater than XL. Third one is XL equal to XC. When XL greater than XC, the circuit behaves like an inductive circuit. When XC greater than XL, circuit behaves like a capacitive circuit. When XL equal to XC, the circuit behaves like a resistive circuit. Okay, so write down this problem. We'll do one problem. The problem and derivation also very important. So numerical. A circuit consists of 10 ohm resistance. A circuit consists of 10 ohm resistance, 15 millihenry inductance, and 281 microfarad capacitance in series. A circuit consists of 10 ohm resistance, 15 millihenry inductance, and 281 microfarad capacitance in series. The supply voltage is 110 voltage. Calculate the current when the supply frequency is 150 hertz. It is not 50, it is 150 hertz. So they are asking us to find out what is the current. Current is simple. Voltage, what is the formula? We already studied. V is equal to I Z. V is equal to I Z. From this, we have to find out what is I. We know what is the value of voltage because voltage is 110 volt they have given. And Z we don't know. But since it is a series RLC circuit, just now we have learned what is the equation for finding out Z. It is the square root of R square plus XL minus XC. Okay, they have given only the value of L and C. From this, how to find out XL and XC? XL and XC എങ്ങനെയാ കണ്ടുപിടിക്കുക നിങ്ങൾ പറ. What is the formula for XL? XL is 2 pi FL or omega L. XC is what? 1 by omega C. That is 1 by 2 pi FC. So, this is the formula where we have to, okay, once again, this is the formula that we have to apply for finding out impedance, but we don't know what is the value of XL and XC. How to find out XL? XL you can find out using this formula. XL equal to 2 pi FL. 2 pi we know, F is given 150, L also given 15 millihenry. So if you multiply it, you will get XL. And XC, it is 1 by 2 pi FC. We know 2 pi frequency is 150 hertz. C also given 281 microfarad. From this, you can calculate XL and XC. And after calculating XL and XC, you can find out that XL is greater than XC. So you can use the first formula. Which is that first formula? Z is equal to square root of R square plus XL minus XC square. So substitute in this one, you can find out Z. After finding out Z, what you do is divide Z by voltage or voltage by Z. You will get the value of current. Okay, so all of you complete this one. Let me take the attendance. Anas?
Present, sir.
Aneshwar?
Present, sir.
Anugrah?
Present, sir.
Ashwan? Ashwan? Dhyan?
Present, sir.
Fatima Nada?
Present.
Safa?
Present, sir.
Sana?
Present, sir.
Jodish?
Present, sir.
Kailas?
Present, sir.
കൈലാസ് നീ എഴുതിയത് എനിക്ക് അയച്ചു തന്നിട്ടില്ലല്ലോ.
സാർ അത് അന്ന് സെൻഡ് ചെയ്തല്ലോ.
എങ്ങനെ മെയിലായിട്ടാ സെൻഡ് ചെയ്തത്?
അല്ല, വാട്സപ്പ് തന്നെ.
വാട്സപ്പിലാ? ഓക്കെ, നീന്നോ. മുഹമ്മദ് മുവാദ് ഫറൂഖ്? മുവാദ്? നീഹ ഷെറിൻ?
Present.
Present, sir.
നിഖിൽ ദാസ്?
Present, sir.
പ്രണവ്?
Present.
സായൻ?
Present.
ഓക്കെ, നമുക്ക് ഇന്ന് ഇത്രയും എൻഡ് ചെയ്യാം. ഓക്കെ, അതിനു മുമ്പ് നാളെ നമുക്ക് ലാബില്ലേ? ലാബിന്റെ സ്റ്റാറ്റസ് എന്തായി?